today for this session we have Shri Sarwan Singh, who is a Principal Training Officer and Deputy Director Systems with National Institute of Electronics and Information Technology. And he's a very humble and wonderful personality. I have visited him personally in his house also, and a very warm host. And a brief introduction to him is recently he was a part of the 40 plus 5 members team that was sent by Government of India to Taiwan. There is a company named MediaTek that is into in the international domain, working in the development of mobile phones. Since under Make in India, government wished to have that kind of mobile manufacturing facility in the country. So they MediaTek, in collaboration with Government of India, offered that we are ready to train your people on our chipset, and if using that chipset, if you wish to go for designing a mid-range mobile, maybe around $100 plus or minus pricing, so we are ready to offer you. So they offered around it was 4 weeks,
6 weeks.
6 weeks. It was a 6 weeks training program, housed in Taiwan only, and he was a part of that team recently. And otherwise, also he's a very knowledgeable person, and in any aspect you can ask any questions. And today I have requested him to engage a session on designing e-services for an educational institution, a demonstration in which he will elaborate upon a Raspberry Pi, the kind of pocket-sized computer I was sharing. He will be discussing Raspberry Pi and its potential and how we can use it efficiently for designing e-services in our educational institutions or any day-to-day activity. So I welcome you, sir, to this program. So we have 4 centers connected with us. One is Government Polytechnic College Janla from Maharashtra. Then we have MMU Ambala, Haryana. Okay. Then we have Gandhi Engineering College from Odisha. Then we have Government Women Polytechnic College Jaipur. Yeah. So we have 4 people, and we have 3 people sitting over here also. They are from Government Polytechnic Namarana in Haryana, then Singh near Jind, and we have from Government Polytechnic Chika, Haryana, and one from Eternal University from Himachal. That's it. So I welcome you, and I request you to engage the session with the audience. Welcome. Thank you. Thank you.
Thank you, sir. Good afternoon, all of you. Sitting across me and across the Pan India, right? All the 4 centers which are connected. Thank you once again, Amardev ji and all the staff of NITA for arranging and maintaining this all facility provided by you, provided by Government of India to you, and utilizing it for efficiently to educate the masses. Right? That is very important. If we have the services, we have the technology, but if we are not maintaining, that becomes a blessing in disguise, right? So myself, Sarwan Singh, I work in National Institute of Electronics and IT. It's an autonomous body under Ministry of Electronics, headed by our Minister, Honorable Minister Ravi Shankar Prasad ji, right? And we have a pan-India presence, this NALET, and we have 34 centers right across every state capital, right? And we take care of the capacity building leg of the Indian government, right? So whatever government has to implement in a capacity building, training activities, training the masses for any vertical, that has been propagated through us, right? And I work there as a deputy director, right? And sir shared already that I have a experience in the different verticals, right? So I have experience in the software and electronics domain both, right? And now I take care of different application perspectives, implementing Government of India projects, right? It may be electronic domain projects or IT domain projects for the women or the masses for SCST or any other different type of vertical. So let's run through the agenda item for today, right? Agenda seems to be very short, but we want in-depth knowledge sharing. Rather, I too will be inviting a two-way communication, right? If you have any doubt anytime right across, you can share with, you can just ask me. I'll stop me in between, and I will be happy to see.
So we have to take questions at the end.
And okay, right. Okay, right. We'll take the questions at the end, right? Thank you. And agenda today, we will be discussing what is Raspberry Pi, right? First of all, this Raspberry Pi is enormous potential it is having for a country like us, right? And what its role in the education we will see. Then we will leverage this to the virtualization, right? Virtualization is a very important aspect today. Rather, it has already 1 decade back it started with, and this basically has improved a lot of green initiatives in the computing, right? Then beyond this, we want today, we just don't want to stop anywhere in between, right? Our scientists are always trying to excavate a new and new avenues, right? So this, we have a new technology, rather not new, or rather it is again 3-4 years back, we started with that, Docker containers. And Docker container, basically we want a virtualization to be taken to the another level, right? So that was not sufficient. A few more intelligent people, right? And one of them was very great, University of Cambridge, the person who is an Indian, right? I'll share the details of his as well, right? He basically brought it to the unikernel level. That means we don't want even full stack of software, right? We just want that software which should basically work for my application, means one process, one application. So there is no problem on the security aspects and number of things. We'll talk about the unikernel, and this all overall thing will build up a green IT initiatives, right? Means this will all reduce the carbon content, improve the efficiency of our working, right? With a very small miniature hardware, right? So let's start with the Raspberry Pi. What is Raspberry Pi? So Raspberry Pi, in a very simple terms, if I say, it is a small form factor, little PC, right? And it's developed by whom, right? So small factor basically means it is a credit card size computer, right? You can see in the pic that it is hold in the palm of a person, right? That too, it seems to be very short. It's a little PC. It basically emulates everything. It can run anything which basically a PC can run. It can run your MS Office, spreadsheet, word processing. It can run games or videos and everything, right? That to a very high definition videos also. So that means this entire PC can be just put into a small box, and it is developed by open source. Basically, it's a Raspberry Pi Foundation. It's a UK-based charity organization, and the website is also mentioned over there. So there is no problem on the aspect that if the company start charging me something, he basically takes away my data. Lot of concerns today we see in education institutions as well, not only in a commercial aspect, that if a company starts charging me on the later side, right, when I start using it, my whole process will stop, right? They will have some commercial aspects coming inside. So this is our open source thing, right? And very cheap as well, right? There's a $35 computer overall, credit card size, right? We'll see how it originated and what version today it is available. We'll span through few slides. So Eden Opton, right? He's a founder and trustee, right? He always wanted to work for the students, right? So that students should learn programming. They should be interested in the problem solving activities, right? And methodologies. So he basically wanted to develop something, right? So initially it started from Alpha, BBC computers and all that, right? So he thought when he started working at the Broadcom, he thought that why don't we have some hardware basically which emulate everything, right? And it is too cheap so that everybody can use it. So initial sales in 2012, when they came up, right? They came up with the idea. They thought, why not do Element 14? And the RS basically was told, we are having this particular board. I want to sell online. Just see how many queries are there. So first batch, what they wanted to sell some 30,000 boards only, right? Initially they had 10, but they thought with 30,000 queries we can have or entertain. Within few minutes, that entire boards were off the shelf, right? They were all bought up, sold, right? So they immediately stopped that from the website. No, we should basically start making it, bring it to the online, bring it to the market. Then only we should open it for the market. Otherwise, it will bring a bad name. So there were 2 million request orders by the time, right? Where people started working on that. They said, okay, we want this. Now it's a standalone company, right? They have a lot many people working on this open source project, right? And this hardware is accompanied by a lot of open source software as well, right? Basically, the first version which you see on the system on the this screen itself, this is the first version they had, Raspberry Pi. It's a single board, ARM 11, 32-bit, 700 megahertz processor, right? This was a very old one. right? And they have a GPU, Broadcom from Broadcom itself, HDMI, Ethernet, RJ45, USB 2.0, and it was only $35, right? So this was the version 1 they came up with, rather release 2. Release 1 was having a less RAM. They had a 256 MB RAM and 512 MB RAM, both together, both in 2 different versions. So what software it runs? It runs any software. Basically, it runs Linux, because Linux is open source. So we have to understand first thing that there are 2 aspects in the world. One is commercial software and other is your open source software, right? So people, those who want to develop something and earn money out of it. So if it is commercial software, it becomes difficult because total cost of ownership is too high, right? So initially, before thinking anything, I have to buy some software, then only I'll work on it and produce some application software which I can sell. But whereas if it is an open source, it becomes very easy for me. Today, we can see we can compare this in the mobile market also. In the mobile market, we can see that smartphone industry in India is booming, right? We are in the top 3 players, smartphone buyers, right? Smartphone penetration in India was on the 3rd position last year, but this year we have crossed the second partner, the second in the list, that is USA, right? With 6 million plus. So USA is selling just 198 million smartphones, but whereas India is selling now 204 million, whereas only one ahead of us, that is China, selling 600 million smartphones. So all the smartphone which is sold nowadays, if we compare the software on that, 83% of the smartphones are using open source software, that is Android, right? Rather, if it is important to certainly say here that Android was second to come before Apple, right? Apple came earlier, that iPhone came earlier, some 9-10 months earlier than first Android phone. But rather, starting late, it crossed the entire market, right? And now you can see it is on the top, right? And sooner or later in this quarter or the next quarter, you will see that the iPhone, the Apple's market share will drop to single digit, right? That is certainly, it has to happen, right? And moreover, the tech giants like Nokia also, those initially tried to bar themselves from the open source Android software. Now again, they have came up, right, with the Android phone only, right? So that is the power of the open source software. That reflects over here also. It supports Linux, which is open source, right? Important thing to say here that Linux too have number of distros, right? Number of distros the Linux is having, right? If we just talk of the distros distributions for computer, right? On a PC based Linux distributions like Red Hat, Caldera, Nobig, SUSE, right? Number of Ubuntu and all other distributions are there. And India is also having its own. I must say here, although I have not mentioned over here because that is not point of this my concern this right now at this PPT, but whereas India too have its own distribution of Linux, right, known as BOS, Bharat Operating System Software. So we all Indians must be very much delighted, and we must be very proud of this, right? That BOS, we have our own distribution, right? So similarly, as we can see in the PC market, we have a lot many Linux distributions. Similarly, that same Linux distribution was cut down for the Raspberry Pi also, right? Now, important to say here is Raspberry Pi is having, right? I'll just share one thing. I'll just use a pointer here to tell you that these are some HDMI interface. This is a HDMI interface. It is having, right? You can see, right, USB right over here, and RJ45 and a USB right over here. But important thing here is how this is booted. Where is the software component, right? Where do you want to have a software? For the software, we have just a memory card, right? And it supports, now this version supports from 4 GB onwards to 128 GB size of memory card, right? So initially it was like 2 GB and 4 GB sort of thing when initially it was released, right? If we don't talk of the right now, right? So then also they basically made a distribution, Linux distribution compatible for the Raspberry Pi, right? With 2 GB limit also, right? So there were too many distributions. So we have Raspbian, we have a Debian, we have Fedora, Arch Linux, Rex, free BSD, net BSD, number of things are there, right? This list keeps on increasing. But whereas now the most favored one, right, when this the fever of this Raspberry Pi keeps moving, now we have already 2006 second quarter, we have already sold 8 million Raspberry Pis in the market, right? 8 million. So that figure is very important for us to understand that if world is believing on that, we too have to use it in order to have better penetration of IT literacy in India, the country like India, where we can't afford a big or costly laptops or PCs, right? So this is very cheap alternative, because it basically, in the last slide itself, you can see over here, I can connect here HDMI, or I can have a RCA, and all the different type of connections are there. So this can work directly with the older TV also. So older screen, CRT TV or LCD TV or whatever TV you have in your place. So every household can just afford with this. So your normal TV can become a smart TV, right? Simply if we say, or your normal TV can become a computer, a PC as well at your place. So later Raspberry Pi Foundation thought, why not to have something straightaway and the best, which includes everything. So they made Raspbian, Raspberry Debian, right? Debian was modified for the Raspberry, and a new flavor, new distros were published, that was Raspbian, right? And they named it new out of the box software, Noobs. Noobs, the easy operating system installer which contains Raspbian. Now, why Noobs was there? Only if one distros is to be loaded, so suppose Raspbian. So I should give a Raspbian in a card, memory card, and he will just load it and come khatam. But whereas they wanted that user should not stick to the Raspbian. Suppose I have a Raspbian and Debian and Fedora, both three options I want to give. So they have given 5 options in this Noobs. The 5 options are given. By default, Raspbian is there. So if user doesn't want Raspbian, he wants rest of any one out of that 4. So he can just go to the menu screen, right, using Noobs, and he can choose the any other one to get download from the website, from the foundation website. That means he can use any flavor, right, using Noobs, or rather he need not to go here and there and download from there. Noobs was basically, everything was made simple. So they got a 5 different distros listed inside the Noobs. Now important thing, what different programming aspects or software which are there, right? Now Linux by default comes with the C language support, right? That we already know, because the mother of C language is Unix only. And from Unix, the Linux evolved, right? It was, you can say, a graphical version, or Linus Torvalds version of Unix was Linux, right? So C is by default there, whereas few other languages which have a good market credibility and a support, that is already been included by default, right, in the Raspberry Pi, in the Raspbian, right? That is Python, BBC Basic, C, Perl, and Java. So this few things are there, right? Few things are there. Rest you can download, there's no problem, right? As we can work on the any Linux box, right, and Linux PC, right? Similarly I can work on this Raspberry Pi. There is no difference in that, right? So in last, I can conclude with that, you can run any software which runs on Linux. Raspberry Pi can host any software, provided you must know, and we must keep in mind the physical hardware capabilities of this particular box, right? That we must keep in mind, right? So this is the newest one in the town, that is Raspberry Pi 3 plus or 3 model B, right? So this figure I took it from 1114. This is self illustrative. We have a 4 USBs over here, right? We got a 10 by 100 LAN port, RJ45 or Ethernet port. We have an audio composite jack now, that we don't have audio and video separately. That was in the last picture we saw. We have a camera interface. You can connect a camera also. I'll show you in the next slide, right? We have a special camera being made for this Raspberry Pi. It is available. We have a full size HDMI video output, as we see in the other devices, fully compatible. No separate thing is required. Only if you want to connect your old monitor, you need to have a USB to VGA converter, right, connected over here, available in $250 or so, and your monitor can become basically smart, right? Or your TV can become a smart PC. So here it basically runs with a micro USB, right? Micro USB over here, that is available with us. There's no separate type of connector, 2.5 amps connector, right? And other micro SD card below this, right? A micro SD card. Initially it was not micro, right? We have now in this particular chipset, Raspberry Pi 3, it is coming. Why this is very, you can say, eagerly availed this opportunity, or it was eagerly bought by the customers, because it has a Bluetooth and Wi-Fi both together. Right. Initially, no Bluetooth and Wi-Fi was there on the chip. Right. You need to have additional hardware connected with this, but now we have additional, no additional hardware is required. We have a Bluetooth and Wi-Fi connected right on the board itself. Right. We have a Broadcom BCM2837 64-bit quad-core CPU. It's a quad-core CPU right on the board, right, with 1 GB of RAM and 1.2 gigahertz of frequency, right? So this is best, again, the best in the class, we can say, right? We have this GPIO pins available over here. What is the GPIO pins? It's a general purpose input output. Now we know that the world is moving towards IoT and all other aspects, right? And we can see that last to last decade, you can say the 90s decade was taken over by the use of internet, right? Computing came some 4 decades back, and 90s, the decade of 90s was basically dominated by the internet expansion, right? Every country was using internet, getting connected and all that. So this decade starting 2011, right, we say that it belongs to IoT, right? With 2020, we will be having some 25+ billion devices on IoT ecosystem, right? And India is no doubt lagging behind, but whereas we have a lot of potential over here, right? Lot of potential, because in India, internet penetration is still 20%, whereas as compared to the 80% in the US and all that, we are far low, right? But whereas the usage of smartphones is good, right? It is a good figure. We have a good CAGR of 25%. That is very good. And importantly, the tele density in India is quite high, quite high. The rural, in the lowest one, the rural areas in India is having a tele density, right? Telecom density of about 50%, right? More than 50%. And all the urban areas are approximately having more than 150% of the tele density. That seems to be very good. But whereas some metros like Delhi is having a tele density of 250%. So keeping that in mind, we feel like, or the world feel like, that India needs to be on the telecom, you can say, map like a giant, right? He wants to overcrowd the entire thing. We love the technology. We have a potential to expand. So similarly over here also, if this device, this Raspberry Pi or this single board computer is not used as a computer only, right? I want to use this small box of $35 as a router, or as some other device, basically, who basically have some other, you can say, sensors connected with it. How to connect the sensor now, right? So for that, all we have this input output pins. So initially this was 26 pins in the first version, but now they have increased to 40 pins, right? And my IoT domain, right, and all the electronic guys and the hobbyists are using these Pi or these boxes especially for these pins only, not using as a PC, right? You're just connecting into the computer and using with a keyboard and a mouse, right? But they are basically connecting so many sensors with this, right? And directly writing the code into it, and output they are generating, right? So by extending this Pi, because initially we just had 6 or 7 million Pi sold without this Wi-Fi and all. But when they thought that we should have a Wi-Fi and a Bluetooth on this, because it was too much demanded, right, by the community, right? And when they had this, the exponential growth, exponential sale accompanied that, yes, it was most awaited one, right? So in the IoT ecosystem, we want that device to connect to the different, basically, sensors using Wi-Fi and others. So simply this chip is marvelous nowadays. So that's why it is sold so much. Right. So Raspberry Pi 3, as I told you, the processor which is connected here, it is a Cortex A53 CPU, which is one of the best of its class, right? And many of the smartphones in the category of 12 or 15,000 rupees available in India are using this particular CPU, right? At 1.2 gigahertz. Video core processor is again very good, right? 300 to 400. Right, 1 GB of RAM and wireless, and a consumption of 4 watt only, right? One estimate says that the cost of the Pi, the box, basically is same as the power consumed for 1 year, right? That means such a low power it consumed, right? If it is run for the years together, right? So it basically equates to that. So that means the power consumption is not too much for this. So when this this trend Raspberry Pi came into the picture, and it keeps moving, then people thought we want one cut down version also. Now suppose I want to make my TV as smart TV. So smart TV means I doesn't want a keyboard and mouse connected with it, right? I just want the TV to listen to me using my remote, right? And change the channels and all that, right? But it should be smart enough to go to the browse the internet and all. So I want a cut down version. I don't want USBs, I don't want RJ45, or I don't want number of things over there. So I just want a display connected to it, right? Or some other IoT based system. So IoT based system basically means that I have developed some program, I just loaded into that chip. Now the chip has to be connected to the network, that's all, right? I don't want to see the output on the chip, right? Or I don't want that mouse and keyboard should be connected, something like that. So one cut down version with a $5 cost only was made available in the market, Raspberry Pi Zero, right? Now rest all things remains the same. Few things are cut down. One is, you can say, the size that person is holding it in the hand, right? It's a small chip with 2-finger chip only. This much chip is there. CPU is the same. RAM is 512 MB, right? Power is 5 volts, same that the previous one we saw. But whereas the capacity, the drawing power is too less, right? The size is too less. Video, audio, and other things are same, right? Storage is on the same SD card. That means if I have Noops installed on a Raspberry Pi, I am working on it, right? I programmed it, I connected keyboard and a mouse with it. I'm satisfied now. I'm satisfied that now this is good. I can host this. You just take out the card from there, memory card, right, and put it into the Raspberry Pi Zero and host to the ecosystem, in the IoT ecosystem, suppose. So it will keep running over there also, right? So again, this one, Raspberry Pi Zero, is too much in demand for IoT based ecosystem or something like that, not for the usage of PC and all, right? You can see over there that there is no pins also in the figure below, that the place of pins is there, but pins are not protruding outside, right? It is not protruding outside. वो हमें दिख नहीं रहे वहां पे. That means they wanted that if you want to have certain number of pins or certain the sensor is to be connected, use that hole or that place, right? We don't want to increase the load, or we don't want to change the you can say the outlook of that particular chip, because this chip can be easily inserted into an 12 mm or 15 mm space, but whereas there are the pins, you need to increase the size of that particular space in which it is to be inserted, or it has to be kept. So that's why it was very meticulously planned and very well accepted by the market also, right? There is no change still in this Raspberry Pi Zero since its launch. It is used as it was developed. So I suppose we know the ecosystem now, right? Here we have a 40-pin header, right? We have all the RC and composite jack. You can connect a jack over here. It is not that the jack is not present, so we cannot connect. We have a place over there where we can connect this jack, right? We have a power USB data port is also there, right? Broadcom chip is there, and a HDMI connector and the SD card, right? Same on the same flow, right? You need not to basically reverse the chip in order to insert it, right? So this type, this way, they basically wanted the chip to become successful, available in the market. Another pick for this. Quickly, we will just compare these four together quickly, right? So on the Pi A plus, initially they launched, I saw shown you one pick, B plus, right, and module B, right, Pi 2 model B and Pi 3 model B, right? These are some of the versions which basically spanned through. Pi 0 is not listed here, right, because it is not to be compared with this is alone, right? GPU is the same, but whereas processor speed, you can see over here, processor speed, right, in this line, right, from 700 megahertz, I have come to 900 megahertz in Pi model B, and then 1.2 gigahertz. Clear. Similarly, the RAM, again, from 400 megahertz or 256 MB to 1 gigahertz HD RAM, right, we have 400 megahertz running. Similarly, the other things also, but only thing over here is today in the market we have a Pi 3, which is basically having a Wi-Fi and Bluetooth, right? Now, I suppose the chip is clear to us, the chip is best of the class. Now, important thing here to tell you that I am not saying that this is the only chip which is available in the market. Single board computer, too many single board computers are available in the market, right? But whereas this is from an open source foundation, it is supported by largest community, right, of its area, right? Single board computer ka jo community hai, in that lot of people support this, not large number of people. So that's why because it is open and number of things have been already been developed, right? It is not owned by anybody. Rather, other things are also comparably similar to the cost, right? But they have not come up so strongly, or they are not open source. That may be the reason, right? So well, next we come up, what are the different applications that we can have over here? right? We can run the entire office if we want to make it a PC, right? Because most of the time we require a PC just to have MS Office and internet, right? Internet means a browser. Browser is by default over there. You can just download a open source LibreOffice, Apache Office, or any office over there, right? Programming by default, Python and Scratch is there, right? Python is a new nerd in the town, right? After C++, ranging through years or decades together and making a most loving language from the programmer community. Now Python is coming up, right? Most of the firewalls and other things are written in the Python only, right? What is this Scratch, right? What is this Scratch over there? I just want to stress a few seconds on that. Scratch is a visual programming tool developed by MIT, right? And MIT basically had a preview that students, young nerds, are not today taking up too much of programming. So they wanted to change the programming, like similar conventional programming in C, VC, void, main, and all that int, char, float. So they wanted to have something called drag drop, right? So they introduced this, right? And it was so much liked by the community. Now we have a offline version also available for Linux and Windows, and we have an online version is also available on the MIT website. You can just go there and create an account over there, right? And your storyboard, you drag few characters and just drag few of the actions and just write in that 20 times do this, right? And pull the actor towards it. So automatically when you run the actor inside that action will make the actor do a particular thing for that many times. So there is no need to tell a student or a kid that now you're going to learn integer char float, now you have to write int char and say void main and all that. So they won't run away from that. Now most of the companies, right, most of the IoT domain is also using the same methodology developed by that particular one, right, for programming aspects, because that is very easy. Any novice user can just see that, right, and just go through once in each different pan and just understand, okay, this is the way we have to program, right? So based upon that, Node.js and all many other things have come up. So Scratch version is by default available in the Raspbian, right? These are few of the things which are there. Now, again, I'll just put across that adding all these things are also having one problem we will discuss, right? So gaming console, we have a gaming console also. There are some distros available from the Raspberry Pi community, right? They are especially for the gaming aspects, right? You can download that image from the website on the Raspberry Pi, okay, or on the relevant website open source project, right? And just copy it on the SD card and use the SD card to boot the Raspberry Pi. How to copy and all that, we will also have one slide in between, right? So you can have a media center also. Sometimes people want to have a home theater at their place, right? Home theater today are very costly. So we have a music system and we have a visual display unit like TV and all that. So I want to put it together, right? So I will have a Raspberry Pi and I will install this XBMC. This already is there. This is already there. These all distros are already there. We just need to download it and install and it will start running. So similarly, we can have a camera module also, right? Initially I told you that there is a camera module over there. So this is what is basically a camera module, small camera module available a few dollars, which can be directly connected with your Raspberry Pi, and it will start working. So these are a few of the applications. So what is Noops and how to use it, how to install this now, right? Very important. If I want, I just bought a Raspberry Pi, right? And I have a SD card also with me, right? Say 5 GB or 6 GB of SD card, right? Make sure that SD card nowadays comes with speed, right? The speed of the Raspberry, speed of the SD card basically, or micro SD card basically comes with the classes, right? They are represented by the class 5, class 6, class 10, up to class 10. So if you want to use a SD card for Raspberry Pi to boot or Noops and all that, right? We should have at least a class 4 SD card, right? Now it is not very costly, it is cheap one, right? So one class simply says 10 MB of the speed. So a good speed card, if it is class 10, it is far better, the best, right? We just bought a card, right? We just bought a SD card from the market, right? Say class 10. And I downloaded the Noops from the raspberrypi.org. This is important, right? raspberrypi.org I downloaded. So I just inserted a card here, right? We have a card 4 GB or so. So when I download a image from there, it will be of 2 GB or something, right? So I want to load it on the card. So it can't be directly loaded on the card. We have to format the card using a SD card formatter, right? So that it is readable by the Linux, right, or Pi compatible. So we can download SD card foundations formatting tool, right, freely available on the internet. So I will download a SD card formatting tool from the internet, very small, few MBs only, right? And after opening that, I'll just click the particular tool. It will something of say it seems like this, right? After formatting a card, I am going to write the image onto the card. So simply it is this. I will open, flashing the SD card using Windows, download the distribution, extract the distribution, and it will be some image file, right? It will be some image file. I just named it as distribution image dot distribution name dot image. It can be SBN, it can be JSC or something like that. So some image file will be there. So I can't do just simply copy, drag and drop the image, because that SD card need to be understood by the Linux or the Raspberry Pi. So I just formatted the SD card using the SD card formatting tool that I have downloaded from the internet. So after formatting that, I will just copy the distribution, the image file, distribution image file, using this Win32 disk imager tool, right? That we have download the Win32 disk imager utility that I have written here in the step, and run the utility. So it will ask you, you want to run it. If you are running on a Windows, it will all definitely ask you, you want to run through the administrator. You'll say yes, it's the administrator option. So check that one and select the image you want to run. So suppose I have downloaded the image and kept in the temp directory on my C colon. So I'll just go from here and I'll say C colon temp and distribution, the image file name I will select, and automatically device is showing E colon. That means this Win32 disk imager will automatically detect the that the SD card is basically connected on my E colon or any drive, any particular drive. So if this drive is coming over there, that is clear that the card is being read and it is hooked up. But it is hooked up by this Win32 disk imager utility. So by just clicking right on that, entire image will be written. Now suppose if I have written the image and I have started doing some changes in the Raspberry Pi, I opened the Raspberry Pi and started doing some changes. I wanted, or I installed few more things, right? I installed few more things which are required for me. Now I want to distribute this entire things which now I have installed to my colleague also, or to the 10 systems. So I need not to again download and do all the same thing and download on every distribution. I can write this image in this card to new cards also. So for that, we can just use this particular tool itself, Win32 disk imager, right? This tool, right? Here we have a read also. So this read is there, right? This read is basically to read the distribution, read the image kept on this particular device. So I will just take out the device card from my Raspberry Pi. I will connect it by my computer, right? And from there, I will just select this E colon, and here I will name some image, right? And I'll say read. So read means he will just read the entire image kept on the SD card right at that time and keep a copy on your system. So next time you can push a new card into it and this images can be written. So it is very easy rather. We were very happy when we started with all this, right? For Education Institute, I'll take a case study right over here. Before going ahead, suppose I belong to a college where there are MCAs going on. So we got a 6th semester or 5th semester or whatever, 4th semester. First semester's requirement is different from the second semester. Second semester is different from third semester. So I got a one PC rather, in which I have loaded all the things for the first semester, second semester, third semester. So first semester guy comes, he doesn't know anything. He just try to do something and he crashes the entire PC. The whole stack is down. Now the problem is for the third and the next two students, right? So we wanted that we should separate it. So what we did is we made a card. We made a Raspberry Pi distribution and we downloaded all the things required by first semester student. One thing, I just made it complete box, right? Now, whenever the first semester student comes, I'll just push in the card kept made for him, right? With all the applications, and he will just enjoy his own application. The important thing is the entire domain of hardware is free. That means he doesn't have anything for the second or the third semester, only thing which is required by him, right? That was the one advantage, right? He can utilize the whole hardware stack, one. Second, there is no security issue. Third, there is no hard labor. Now, very importantly, that if user, or if a student is doing something of his own, he wants to maintain it. He doesn't want that it should go on the cloud or something like that. Suppose there is no net connectivity at all. So he can just take the card, and hardly that card, class 4 card of 4 GB or 8 GB is available for 250 or 300 rupees. He can buy his own card also and copy the entire thing on it, and he can start using it. But suppose if the boy is not having the hardware with him, right? Now that also was thought by Raspberry Pi or the different people in the community, that if somebody is using a computer, but he's having the image with him. So there are some tools, Q menu and other tools are available on the web, which you will download the tool on your computer. Suppose I'm running a Windows box, I'll download it on this. I will push a card onto my system, right? And the card will be treated as the input to that particular environment. And that environment will emulate the whole Raspberry Pi in front of me. So I need not to have a hardware also. Sometimes if suppose things crops like that, the hardware is not available, I have a card with me with all the backup image. So I can use the image to use on my Windows box also, right? That is also there. So one, we have leveraged the security or the different aspects. Second, every user can maintain its own card. Similarly, it emulates to the some a decade before example, when Linux distribution was available on you can say removable media like pen drive. We used to boot the Linux from the pen drive. So we made every student hang a pen drive over here. He will just go to any of the system, plug in his pen drive and switch on the system. So the system will boot from the pen drive. So entire system he is looking at, it is not from the hard disk of the box, from the computer. It is basically from the pen drive. So whatever he is writing and saving, that goes to the pen drive. So once he shut down and takes out the pen drive, that entire thing is with him only. Same way over here, we can do it. Right now, important thing over here, we saw that a Raspberry Pi is there. We have 1, 2, 3, 4 softwares are installed. Everything is good running. I suppose working on one particular application or the software, I don't require any other software. Right now, I unnecessarily basically overcrowdedly or overwhelmingly basically put all the software which basically occupies the space. My SD card is full. So whenever I switch on my Raspberry Pi, all the services are activated, right? Whether I'm using the tool or not, software or not, but the software is installed, that means some service is activated in that, right? That service will come to the forefront only when I'll click on the particular icon. But whereas it is there, right? It is there. He has to maintain a space for him. Yeah, sometimes the user may call up to this, right? So there comes now comes the virtualization. Right now, this aspect directly doesn't relate with the Raspberry Pi, because this Raspberry Pi age is less than the virtualization. Virtualization started some 15 years back. So virtualization is nothing but, we say that when the servers were become costly, right? We wanted to run multiple applications or multiple OS, right, onto the server. So it was not possible. We used to have a dual booting type of thing, but whereas in dual booting, only one OS can be in the picture at a time. So we want to run both the systems, right? So for both different OS, we require to have 2 different hardware. But this increases the carbon footprint, right? The power was not efficiently used, right? The servers were not optimally used, right? They are just running 24/7 and not even going beyond 25% of the usage. So we try to accommodate all the things into one, right? So for that, we came up with the idea of server virtualization, right? So we just write over here, server processing power and capabilities has increased a lot, but bare metal applications were not able to utilize the resources. The resources were not able to optimally use the hardware, right? So virtual machine was born. Virtual machine simply, right, basically is a software running on top of the physical server, which in order to emulate the particular hardware. We'll see a picture over here that traditional architecture is this, right? We have a traditional architecture in which hardware is there, OS is there, and application is there, right? Now suppose one app requires Linux, right? Linux OS, right? So Linux OS is installed on the hardware, but some app requires a Windows OS. So the hardware, this particular hardware cannot run 2 OS at a time, right? So the idea of hypervisor, the virtualization came into the picture, right? The hypervisor or virtual machine monitor is a software firmware that creates and runs the VM. So this came to the era, right, of virtualization, virtual architecture. So I'll just try to put stress onto this particular thing, that when we saw this, a decade old, right, technology, right, we saw it, we were amazed that how good it is. But one particular hardware, suppose I got a server of 4 GB RAM and some 1 terabyte of hard disk is there, and 2 Xeon processors are running in that, right? Costing about 2 lakh rupees or so, right? So I have one top of that Windows running. So that Windows server is good for .NET and all that, but we need some PHP server also there, or some Apache server also to run on that. So I wanted to run, or MySQL to be there. I want to run on the Linux box now. For the Linux box, I have to shut down or I have to take down this particular Windows box. Both can't run together. So this basically architecture came into the picture when you want to run 2 different OS at the same time, or more than 2 OS at the same time, provided knowingly that no OS requires more than some say 2 GB of RAM in our example. Suppose I got a 4 GB of RAM or 8 GB of RAM on the server. We know that one server is very well managed by 2 GB of RAM, so that we can run now 4 different machines or at least 3 machines at the same time. Resources are good and available. So we basically introduced a concept of hypervisor. This hypervisor was basically introduced in between. Hypervisor is nothing but a software or a firmware, means a layer between the OS and the hardware, right? The person or the application sitting on the OS, right? The application running on the OS, like for example, Apache web server running on Linux machine, right? And similarly, IIS running on Windows machine. So they are 2 different machines now. Now I want to run 2 different OS, right? OS number 1 and OS number 2. Let's say over here we have 2 OS, right? So this OS basically, suppose this OS 1 is for Windows and OS 2 is for Linux, right? Now these 2 are different separately running the 2 applications. Now hypervisor is basically emulating that 8 GB of RAM, dividing 2 GB for OS 1 and 2 GB for OS 2 and keeping 4 GB separate, right? That hypervisor is doing all that, right? Hypervisor in between is doing all that. So similarly, if third OS comes up sometime of the other, so he will give him rest of the 4 GB, whatever he needs. But suppose if the third OS needs 5 GB of RAM, right? That can also he can accommodate, because he knows that it is dynamic allocation, and currently both the OS are using only 1 GB each. No doubt the upper limit is 2 GB, but whereas they are using only 1 GB, so we have got a 1 GB spare from OS 1 and 1 GB spare from OS 2, and total 6 GB is free. I can make this 5 GB run, right? So he will allow him. So sometimes these 3 are running, but if we add them together, the RAM requirement is too high, which is not physically possible. This all is being emulated by the hypervisor. Now the hypervisor again was commercial and open source, right? This is again point to be noted here, that Zen hypervisor was open source, and others like VMware, the top virtualization tool available in the market, having a good amount of percentage, right? VMware and others, VirtualBox from Oracle, right? And similarly, some Hyper-V from Microsoft also. There are some other hypervisors in the market, right? From different software giants, right? Some are commercial and Zen is the free one, right? So this is how we were able to see that now we don't require multiple physical machines. We can optimally use the hardware using this hypervisor for different OS, right? And different applications running on top of it. Now, suppose if the OS 3, the third OS here crashes, right? Suppose this crashes. Now, this won't affect any of the other 2 OS which is running. That was very great on that. This third OS, if it crashes, I want to make it down or it shut down abruptly or somehow, whatever, some problem crops up in this won't crop up into the third one, right? And Zen, the Zen hypervisor was based upon the Linux only, right? So if suppose there are 2 servers running, and both the servers are using same hypervisor on the either machine, either hardware. Now we have tied up them together, right? We have tied them together, right? Sometimes there are 3 OS running here, VMs running here, 3 VMs running here. So we call this entire thing as one VM, this entire thing as one VM, right? So there are 3 VMs running here, 3 VMs running here, right? One goes down, means the user makes it down, other user makes it down on this, only one is running here, 3 are running here, right? Total full. So here also 2 goes down. Now this entire, both the hardware are now not optimally used, because only 25% of this is being used. Here also 25%. So this will swap it over here, right? The hypervisor will talk to each other and say, boss, you take down this particular VM from here to here, right? And we'll shut down this particular hardware. So this is how efficiently we were using the power, right? We were reduced the carbon print, right? And everything was too much, right? On the fly, these things were used to change, right? Suppose we started a VM over here, right? And the VM was told to have maximum of 4 GB of RAM. Max VM, you required 4 GB of RAM maximum, but whereas I'm using 1 GB only. But gradually I'm trying to put the load more load is on that, right? And I'm crossing a limit of 3 GB. So I know there is no RAM left on this hardware. So automatically this VM from my right. So I can change one VM from one particular machine to another particular machine. So that all on the fly, hot fixing, everything was available, and it was amazing virtualization. So we had no need to have a single application, single server. Cost was saved, reduced footprint, right? Faster server provisioning, improved disaster recovery, and number of things. If some hardware goes down, this entire hardware goes down, immediately I'll take off the VM from here, right, and I'll keep it out somewhere there, some other hardware, right? So no downtime basically, right? So there are a number of advantages the virtualization was having. Now the problem comes up over here. I just want to show you this figure again. Now problem is over here that which we realized a couple of years back, not 15 years back. When this virtualization came, we were very happy to do all that. But now we feel like if we want to run one app, right? This app may be requiring some part of the OS only, right? I may be requiring some part of the OS only, right? Or some services of the OS only. Suppose I am just running a simple, you can say, database application on the server, right? Some MySQL or something like that, right? But the OS has a complete stack of things, right? OS has a complete stack of things. So this app requires only this much, right? But OS has everything. So OS is unnecessarily occupying that much percentage of the hardware, right? This OS one is given 2 GB of RAM, suppose, right? But my application just require 512 MB of RAM, right? So does OS, when OS boots, he basically have number of things with him. OS has number of things. He has all the services. All the services accommodate in the space, right? And only 512 is given to that particular app. Rest the OS is consuming unnecessarily. So people started thinking that why not to cut down the OS also? If we take down the OS in between, something good can happen. Yes, that happened in the next thing we want to talk here. So this is Docker containers. This is a very new concept which came. Docker is an open source project that automates the deployment of applications inside a software containers. Now I want to contain the things together, right? I don't want the OS to have every time OS to have between the application and the hardware. So OS has its own whims and wishes, right? The load of OS unnecessarily is being there on the entire system, on the resources. So Docker provides a way to run applications securely isolated in a container, packed with all its dependencies and libraries, right? Now I want to run one application, right? That one application may require out of the OS this 10 libraries, right? Out of the 100, I require just 10 libraries. So I want to cut down these 90 libraries away. I want this 10, I want this application, and other OS kernel libraries, if any dependencies are there, just plug them together and make one bundle, that's all. This bundle can run on any hardware now, right? With maximum efficiency, right? So that was the idea of Docker, right? And it started a way back. We have just a history here, right? This 2013, basically this project took, Solomon Hayek started Docker in France as an internal project on .cloud, platform as a service. Now, this platform as a service is basically a cloud term. In cloud computing, we have simple software as a service, application as a service, infrastructure as a service. So they wanted the platform to be used for certain set of community people, right? Irrespective of the place and the hardware, right? So they were working on some PaaS application, right? And they thought, why not to have these type of things? So again, the birth was Linux kernel only, right? So they wanted Linux kernel to be used for different things, a lib container, LXC, and all that. So we'll see what is this LXC in the next slide. So it was basically just to make their life easier. You know, in the open source community, it is a platform for many new innovation in the world we have seen and yet to see, right? I must say that the many things were born from this open source platform only, right? Because number of people unknowingly or knowingly basically jump into it, right? It came out with the pulse, right? So if we say that commercial software sometimes just try to exhibit certain behavior of the open source and try to steal the money, right, from those who doesn't want to go into the nitty and gritties, just spend money and get the things, right. But whereas those who want to have everything of its own, they just only go for the open source. So Docker container, the original Linux container, is a Linux container commonly known as LXC, right. In the last slide I told you one is LXC. LXC is a Linux operating system level virtualization method for running multiple isolated running Linux systems on a single host, right. On a single host, we want to basically have one application, right. Now I can just give you one figure here. There's a one figure, we will be just pointing towards this, right. This figure, the figure on the left hand side, I can just see here. This part we have already seen in the virtualization, this part, right, where there's a infrastructure and a host operating system, right. Host operating system, there is a hypervisor, right. Hypervisor basically runs on an operating system, right, simple, and this operating system handle the hardware below, right. This hypervisor will basically make one VM, this will make another VM, this will make another VM. The 3 VMs are created. Every VM has to have a whole guest OS. We call it guest OS. This is a host OS, this is a guest OS, right. This is simple virtualization which we saw in the previous slide. So we basically are basically wasting this space here, right. Every guest OS has to be there in order to use the application, in order to run the application. So application 2 requires some binary files which are loaded onto the OS, guest OS, and guest OS is indirectly running, controlled by the hypervisor, running on the host OS, right. So this entire stack was basically disturbing us a lot. So we came to this Docker container. We basically have this particular thing in which we basically have OS up to this part, it is same up to this part, right. We have an infrastructure, we have a operating system. Now we got a Docker engine in between, right. We basically try to get rid of this hypervisor, right. I'll share with you another person's background, right. He was working with the Zen hypervisor only, and he had worked, and then he thought, no, this requires lot of space, lot of infrastructure, right. Why not to use something else? And he was involved into this, right, this particular project. So operating system just have a Docker engine, a small software bundle which runs on it. Docker engine basically removes the requirement, you basically avoids this usage of guest OS and just run the binary files and applications on it. That means the entire stack is reduced. So the hardware resources taken off by this guest OS, right? The hardware resources consumed by guest OS are leveraged now. They are released, right? Now entire resources are with the app only, Clear? So this was the idea behind. So this is the Docker, which started as a project to build single application LXC. We started with a project. We want to have a single application Linux container, right? LXC container. We want to make some application to run on a Linux box, right? We wanted no guest OS should be required, right? You just basically concentrate, or you just take all the library files, binary files of the OS also, which are required to run on the app. It's the same figure, right? Which are required to run on the app. So introduce several significant changes in the LXC that make containers more portable and flexible to use. So this Docker container was this project, which basically created a new level of virtualization, It's not something different, but it is basically avoiding the overload, unnecessary load, right? It was just that. Container in a software. Package your application into a standardized unit of software development. Now suppose I want to basically deploy an application. So I developed an application, right? And I just packaged it. I just made it a final ready to go thing. Now this exe, suppose I am running on a .NET or something like that, right? I made a Windows application. So I just compiled it, ran it, and saw, okay, I made a exe out of it. Or I am running on a C language, or I made a exe out of it. Now this exe requires the Windows operating system with CLR. Suppose it's a .NET Windows platform, .NET Windows exe, right? It will require minimum Windows 7 with CLR, right? For this, then only it will run. It cannot run on the bare machine, first thing, right? So I need to have unnecessarily the whole Windows stack ready, CLR stack ready, right? Then bring this, right? So this entire stack is unnecessarily consuming my space. So they want to get rid of this, and they have got rid of this, right? That's why we now have the small mobile phones and small devices running like anything, right? With such a battery life, I'm telling, I can share with you that some IoT devices we are having now, which have a battery life of 10 years. You just install it and forget it. For 10 years it will start working, because they don't create the whole stack. They just use that much space and then sleep, then again come up, use that and sleep. And the boot time is alarming. I'll share with you, right? If we have this mechanism, right, Windows or the full stack booting, suppose it takes 10 seconds, 10 seconds, or say minute or so, right? Here it takes milliseconds only, few milliseconds. You just switch on, it is ready, right? It is ready to do the job, if it is screen or something like that, right? So package your software means I just made a software. I want to make a contain, I want to contain it in a container, Docker container, wrap a piece of software. Now this Docker container will wrap the piece of software in a complete file system, right? This Docker container, I'll give the software bundle to this particular package, to this particular Docker container. I'll say, okay, get me ready this, right? He will see that how much file system components you require, right? This particular software package requires. So this will basically jumble it or add it together. He will join it together, right? He will collect it together. So in order to code, run, system tools, system libraries, all. So we have number of things here. We have system tools, we have a runtime libraries, or some code time data paths or something, or shared libraries, whatever, system libraries, whatever you require, that all will be collected together, made one bundle, right? So this one bundle is completely efficient in itself. It can run anywhere now without any background, right? Without any base OS or something like that, right? So that was it. Container sits on top of the physical server and its host, like Linux or Windows, right? It just loads on the Windows or Linux. No need to have a separate things. Each container shares the host kernel and usually binaries and libraries too, right? Thus containers are exceptionally light. This is very important. They are very light containers. It is few MBs only, right? And it takes few seconds versus minutes in VM. If you have a VM running with one app, you switch on the VM, it takes minutes, but here it takes few seconds only, right? So it is comparably having a great speed, great agility and portability, right? The portability is very high, right? Portability is very high. That's important. So again, something was missing right here also. Now people at that time itself, when I shared with you this particular pic, people again wanted to have why we need this engine, why we need this entire stack now, right? OS and all. People started thinking in that manner also. Docker is okay, but we too want more lighter version. So very forerunner is this fellow Indian is there, Mr. Anil, Senior Research Fellow with the University of Cambridge. There are so many people, but I want to highlight my person only, right? So I like that. So he has a one Mirage OS ready with him, right? He has worked a lot on that. So what is this unique kernel? What is this unique kernel? I want to discuss that first. One having or consisting of one. Uni means one only. Kernel means a bridge between application and actual data processing done at the hardware level. There is only one kernel now, right? I need not to have one separate for me and separate for OS. I want everything should be one. Directly, I should jump into the hardware, right? And that will be optimally save a lot of space as well. So unique kernel, lightweight, bootable disk images. Now it is bootable, right? You just load it on the system, onto the image, onto the, you can say SD card, right? And put it in the Pi or something like that. Switch on, immediately it will boot. Suppose I just want to see, I'll take up the example of Raspberry Pi itself. I want to just use MS Word, right? Or Notepad only. Clear? I just don't want to see anything else. So I switch on my system in Windows itself. If you will see, I just want to use a Notepad, but I switch on the system. It will keep booting. Number of things will come up. Start button is full. Slowly, it gradually comes up. I just click onto the Notepad. Notepad application is hardly a few KB. Just to use that few KB of file, right? I have to waste so much of time, right? So every time user comes up, he want to write something on the Notepad. So why he should keep waiting for that? So unique kernels is the answer. So it is a lightweight bootable images are ready with us, right? So unique is a tool for compiling application sources into unique kernels. So This, if you want to make unique kernel, this is a tool. Unique is a tool, right, to make this unique kernel for anything, right? Suppose I want my first year guy to have C practicals only. So I just want he should come to the lab, switch on the system. He should only see a C editor, right? He should type C program, run, and finish off, go home. He should not see anything about this Internet Explorer. He should not see anything about rest apart from that. So the answer is unique kernel. Unique kernel are lightweight, immutable operating system compiled specifically to run single application, right? So GitHub source is also there for this unique. Unique runs and manages instances of compiled images across a variety of cloud providers as well as local VirtualBox. So they got a good support throughout the community, right? And that fellow is already working with Cambridge University, and there is a lot of work done by those people for the different domains, right? Applications are compiled into unique kernels like Node.js, Go, Java, C++. Go is basically with a Google, right? Google's language, C++, Python, etc. All these different applications used in the different verticals in industry, IoT or education or any vertical, basically have this unique kernels ready. The result is a machine image that can run directly on the hypervisor or bare metal, eliminating the need for host OS, right? Now, important thing over here is to understand hypervisor and bare metal. Now, virtualization is possible on two things. Virtualization could be done using bare metal or using hypervisor. Hypervisor means we have a hardware, we have a operating system, like host operating system. On that, there is a hypervisor, right? And then starts with a VM, all that, right? Now, suppose I don't want a host OS. So I want this hypervisor to run directly on the hardware. So that is called bare metal, right? Bare metal means directly that hypervisor is controlling the hardware, right? So similarly, as the hypervisor are controlling bare metal, right? Unique kernels can directly run on the hardware. So that is the easiest one for us, and that's why we are correlating here the single board computers like Raspberry Pi with its unique kernels, because it is highly appreciated over here. So if I want a specific application to be made for a K3 or a junior or nursery level students, so I need not to boot the entire stack of Raspberry Pi, right? I will create an image for him only, and rest of the space I can put number of music and image files for him so that he can just arrange them together to make its assignment or something like that, right? So the unique kernel is basically good because it supports open source, and it boots very fast on a bare metal. So here we have a pictorial view of this as well. We have an application. Current application stack is like this, right? As we saw in the previous, we are comparing here also. We have a hardware and we have a kernel. Kernel basically a part of the OS who does scheduling, memory management, process management, device driver, network stack, and all that, right? So we call it a kernel space. This is a kernel space. Clear? Now, on top of that, there are certain libraries, right? And libraries are used at the runtime, then application is run. Clear? Now, suppose the library for C library is there, or some language library is there, or some multimedia library is there, right? Which basically is executed, and depending upon the user choice, right? If user wants some video to play or some notepad or some application to run, accordingly some libraries are chosen and given in the brought to the runtime. Now these two are different spaces. These two are two different spaces. Clear? Now jumping between these two spaces is again very important. Clear? The memory has to be divided for these two different spaces, kernel space and the user space, right? Now if user wants to utilize the hardware to the max also, then also he can't, because that half of the hardware or some part of the hardware is occupied by the kernel space. Clear? So for application to run on hardware, there are many layers, first thing. And second, address space is different. User has to keep his own view and kernel has to keep in view, and then intermittently shift between each other. So it takes a lot of time. It takes a lot of time. So as a system developer or an application developer, we must keep in mind that application should load fast, optimally use the resources, and output should be ready always, right, in no time. So this is what we want over here, right? We want to take this particular figure out, and we want to bring something new. The something new is a single address space, very importantly, right? This is important to understand over here. We want a single address space. We have a hardware, and we want on the hardware, everything should be bundled together. There should not be two address spaces, right? Kernel, libraries, runtime, application, put all together and make one package, right? That one package, once it is on the hardware, right, it should start flying, right? That is what is basically a unikernel. That is what basically we say it is a unikernel. Clear, unikernel based application stack. No privilege transition between user and address space. That means if user wants to access some file, so he has to go to the kernel space and ask, I want this particular file. That address is to be again indirectly redirected to some memory space in the secondary memory space. From there, some portion of the data will be brought and displayed to him. He says, no, don't require this, I want something else. So he keeps jumping between two different spaces. Lot of time is wasted. Here, there is no space. It's a single space, right? High security, because there is only one application running, and that dependencies, that application dependent library and kernel are there. Nothing more than that. Nothing more than that is there. So it is very fast. So that means if my hardware is small enough to accommodate the needs of this application, then also it is good. I need not to have a 4 GB or 6 GB RAM, because I want to shun somewhere or the other that no more hardware should be there, because more the hardware, more the noise, right, more the cost, right, more densely we populated, right, more problems crops up, right? So we want to reduce all that, because nowadays we want to efficiently utilize, right, and reduce the carbon content and e-waste as well. So unikernel tries to remove layers between application and hardware. That is very important. So this is why unikernel is the call of the day. It's a call of the day. And a Pi or all the single board computer, the people who are working on the single board computer are very much with the open hands welcoming this unikernel approach and Docker, because Docker was the initial, then later on unikernel came, and Docker guys started thinking that this unikernel is going to eat away my Pi, right? And then this unikernel was bought by the Dockers only, right? Now it is part of that team only, right? It's complete one stack itself, right? So here we can see the container word is also there. So unikernel means we have a hypervisor, we have a guest OS, right? And the traditional container, we used to see the hypervisor, the guest, and the application running on top of it. Clear? Now this was Docker container, right? This type of thing was Docker container, right? That we saw in the last section. But unikernel approach, in the unikernel approach, we have just a host OS, right? We just have a host OS. We need not have a guest OS right now over here. Right, because all the libraries or dependencies which an application used to have from this guest OS are included already. So this entire thing basically is ready with us, this app and a library OS. We call it a library OS, right? This is called library OS, a new term which cropped up. Unikernel container is an application plus library OS running as a VM. Library OS is running as a VM now, right? Now this so many library OS is already there. The Mirage is one of them, which I just given you a name right in the start of this. I'll again share that slide. That Mirage OS is again a library OS. There are so many library OS already available on unikernel.org. You go to the unikernel.org and see how many this OS, library OS are available. I want to do C++ programming only. One unikernel is available. I want to do Python. One unikernel is available. I want to make my own unikernel. Right, I want to do something apart from these also. It is there. It's open source, right? You just download thing, just learn how to do. I'll show you, share some slides over here, right? And you are able to do it, right? But otherwise, prominent problems which are there in my domain, in the educational domain, right? Which basically consumes a lot of space, right? They are already taken care of, right? We have already had solution for them. Unikernel containers are already there. So that's why we see here the slide, the first slide I took, right? Anil is already working on this Mirage OS. It's one of the very prominent ones. Similarly, at Compute and ULike and UCS, as some type of library OS are there, right? You can see he's a PhD and he's a pioneer in this particular area. He had 2006 onwards, he's working. He was a prominent member in the Zen team also, Zen hypervisor, which was an open source hypervisor for the virtualization I shared with you, right? And now he was not believing the idea of a Docker, so that's why he started thinking something different from that itself, right? And he came up with a unikernel, or this team came up with a unikernel, and now he's having a number of things with him. We can see later on this, right? So this is what is basically our idea, that if a unikernel approach is used, then my app basically can run directly on the OS, on the hypervisor, without requiring any guest OS. So if we compare this with the very first figure, right, if this last figure, if we compare with that very first figure of the virtualization, in which we saw there is a host OS, there is a guest OS, and in between hypervisor is there. Then after that, there is the application running. So once we get rid of this host OS, this guest OS, then there was some engine was there. Now the engine is no more there. That Docker engine is also no more there. Now we have a library OS ready with us. Library OS running on top the application, right? It can run on any hypervisor. This hypervisor can run on a bare metal or directly also. And we can make directly this bare metal unikernels also. We'll see. Now, once we try to make a unikernel for a Raspberry Pi. So for that we have UTBO, right? Is a core embedded or bare metal development environment for the Raspberry Pi. It is not an operating system, but provides many of the same services as OS, right? Now I am not talking to create a OS now, right? We don't. We just want to include the basic dependency or shared libraries of OS into my application, into my software bundle, so that my application run safely, right? I don't want to disturb anyone, right? I just want to take care of some of the library files which are required by my app, and I put it together, bundle it together, and deploy it. That's all. So we are not making any OS, right? So he will take care of the memory management, networking, file management, all that. UTBO core is free and open source. It is again free and open source. That is very important, right? This always has to be taken care of. It is written in free Pascal. That is very important, and is designed to act as a unikernel or a kernel in a runtime library. Okay, right? Some things they have already gave us. Now, example is I want to make a pizza at my place, right? I have only flour ready with me. Right, if I am having a flour, I want to make a pizza, that is not possible, right? Because the making pizza base will eat away most of my time. I don't like to have toppings, I'll just eat it like that. But if I want to relish the pizza, so I'll get a pizza base from the market. Now I have a sufficient time with me to garnish it with anything. So similarly over here, unikernel, some part of it is already ready. You just have to open it, right? Include all the things you require and just run and compile it. That's all, right? So this is how we basically want to reduce the development time, total production cost, and the time as well. User compiles applications and necessary parts are automatically included by the compiler, so that your program runs without needing any OS. You need to just include your things. Rest all it will take care of. Rest all it will take care of. You need not to worry about how the things are managing. So how we go into it, how we start working into it, right? We have a library. We will download this particular exe file that we can see over here, right? Core 1.1.009 cucumber.exe. This library I have downloaded. This file I have downloaded. I'll just install it, right? Double click and install on my system, right? So we have a special note here. Due to a limitation on the compiler, you cannot select the path without spaces in it, right? We should not have a space in between. Directly we will load on a C colon on a directory where there is no space in the file name, on the folder name, right? So we have just started installing it, and these are some of the basic steps, right? And this finishes with the installation, and it small icon basically comes into the start, right? So we have a ID ready, Lazarus ID. So this ID stands for Integrated Development Environment. This as a first thing it provides is a source code editor with a syntax highlighting, auto indentation, auto compilation. That means all the things which are there in the ID are ready over here, right? We need to just include number of things, right, and start deploying it. So here we have this tool. We have a project one ready with us, right? We just created new project, and we have here run. We can include number of files here. We have a tools and similar. These things are same as the earlier one. So once we collect all the things together here, right? We have a certain set of norms which are to be followed. So this is one small set of program, right? Here in the begin and end, we can keep writing all the things, right? Some basic steps are there. And once that basic steps you finish, clear, simplest as a programmer, right? You just have to compile and run. Finish this off. Clear? So here we have a project and a project new, and he says when you create a new project, we have number of sources over here. We can see Raspberry Pi A, B, B plus, A plus, and all that, right? For the application, for the zero or the simple program and all that. So this is specially meant for Raspberry Pi and all I shared you initially. So we have to just select the version of the Pi. This basically emulates the environment of Raspberry Pi, that particular version, right? If we select an appropriate one, he will emulate the environment, what is available over there, means what are the different input, the pins and other resources are there. Accordingly, he will create an environment for you, and for that you will be including. So we will be including all the executable files. We will be using all the files which we want to make an executable file later on, right? And just all the files are units are put together like this. He will say all these files will be collectively brought. Units are very useful way to break a project into the pieces so that related code can be grouped together and reused in multiple places. So we need to include the group of units. So some units are already there. Suppose we want to make a hello world program, right? So these few units, he says just like, and see, we say include this. So here we say uses, right? Some of the other the new languages which comes today with the Python and others, they have very readable sort of syntax. So we have uses. All these, you can say, libraries we are using, all these things which are required by the system we are using. So by default these comes up, right? You have to add any additional down, you can add, otherwise this will make up a new hello world. Simple, right? Simple variable we will create. This variable basically TW window handler, it will create a simple variable, and similarly we can create number of other variables in order to have one complete bundle unikernel with us and finish this off, right? So I hope the unikernel and this approach is clear, how we can make a unikernel here, right? We can take any questions across right over here. We started from how Raspberry Pi works, right? How basically we improved the green IT using virtualization, but again it was consuming a lot of space on the resources. We started having a Docker containers. From Docker containers, we evolved to the unikernels, right? And unikernel for the Raspberry Pi. Unikernel is not only limited for the Raspberry Pi, it can run on any other single board or any other hardware as well, right? But whereas we are targeting from where we started Raspberry Pi and we concluded at that. So I want to share one more case study over here, right? Before taking up your questions, that Raspberry Pi in the education initiatives, we have one of our department in Kolkata has already implemented the project in the Sundarban. Sundarbans are, you can say, a place where accessibility is very poor. That means it is a, you can say, small islands are there, right? And they are very thinly connected, right? Low population density, very poor people are there, and they don't have access to the mainstream resources. Clear. Schools are on one island, and people used to come from the different islands using this water route only. So we wanted to implement some education initiative. So the Raspberry Pi was used. Raspberry Pi using this Wi-Fi was made a small server with LMS, with a learning management system. That means a Moodle was installed onto that, right? And students were given small pads, small, you can say some 6-7 inches pad were given, right? Tablets were given, right? And they used to come, because they don't have a power at their place also, right? They used to come to the school with that particular tablet. They used to hook them up in the class itself, where they start charging. While charging itself, the teacher used to basically release the new video, right? Whatever she has taught, right? That video audio he used to connect in the Raspberry Pi Wi-Fi, right, as a server, right? And it was basically hooked up into all the tablets in a Wi-Fi without any physical connectivity. So all that tablets which are getting charged, they are updated with the curriculum that has been taught today, right? So by the time they go home, by the time the school finishes, right, they are charged, as well as the entire lesson is updated onto that particular tablet, right? Now they go home with that particular tablet, right? and with a charging of say 3 hours or 4 hours, depending upon the life of this particular tablet, right? They used to evaluate along with their friends, because if one person comes from that particular island and rest 2-3 people are not able to come, so he can share with them, right? And moreover, that is a school property, right? So next day, whoever comes, right, he brings that particular bag to the school. So otherwise, if he keeps with it, right, this is of no use, because there is no power in that, right? And they don't have a power to recharge. But if they have, they can recharge and get it basically again activated and reuse it. And whenever they will come to school, it will be updated. If it is after the span of 2-3 days also they come, because there is a rain or something like that, they are not able to come for a couple of days or week. So they come after that, they put it into the school classroom, right? And they got all the things synchronized into the tablet. When they go home, everything is with them, right? And they can use it there. So this particular paper we published 1.5 years back, and it was very much appreciated by professor at the Harvard also and the Stanford, right? And one of my director from Kolkata visited that place also to introduce and get some support, but rather government of India supported this particular project, and somehow it got some shape.
Qualita Day. On behalf of NICCT at Chandigarh and participants at all the nodal centers at this nodal center, I thank you, sir. Thank you for being with us and sharing, teaching the basics of, I would say, electronics in such a illustrative and interesting way. If I would have got my electronics teaching electronics in such an interesting way, I would definitely would have cherished it. And thanks for being with us and with your knowledgeable inputs. Thank you very much.
Thank you.
I will keep on disturbing you.
Thank you. Thank you all.